Welcome to electric fields. So when we study electric fields, there are kind of two big concepts that we're rolling into one. Electricity and how it works, and fields. So you've had experience with electricity before, but probably field theory is going to be new to you. So we're going to start off with how electricity works, and then we're going to move on to what a field means. So first of all matter is made up of atoms. So here's a little quick diagram of an atom. Let's say that the atom has 1, 2, 3, 4 protons and 1 neutron in the nucleus. Here's the nucleus. And then it has electron shells. There's 1 electron shell and its second electron shell. Pretty good circles. In the electron shells, here's the first one. We're going to have the same number of electrons as protons, right? So here's 1 electron, 2 electrons in the first shell, and in the second shell we will also have 2 electrons. So this is a basic diagram of an atom, very simplified of course, but that's really all that we need. So atoms are made up of protons, neutrons, and electrons. Protons and neutrons can be split up into smaller pieces called quarks. We aren't going to be concerned with quarks right now because all we really care about is their charge, okay? Because electricity has everything to do with moving charges. So protons have a positive charge. Neutrons have no charge, hence their name. They're neutral, no charge. And electrons have a negative charge. Okay, so when an object becomes charged, something is happening to its protons and electrons, something like that. Because atoms are normally neutral. Let's try that again. Electrons are normally neutral, which means they have the same number of protons and electrons. And this atom that I've drawn up here is a neutral atom. Same number of protons, 4, and electrons, 4. But when an atom loses electrons, it becomes positively charged. Okay, and hopefully that makes sense. We used to have 4 protons and 4 electrons, and then if this atom donates 1 electron to something else, then we have 4 protons and only 3 electrons. So 4 positives and 3 negatives. That leaves us a net positive 1 charge, right? So when you lose an electron, you end up with a net positive charge. When an atom gains electrons, it becomes negatively charged. When an atom gains electrons, it becomes negatively charged. So in order to fill up its outer shell, it gains another couple electrons. That would mean that now it's negatively charged because it has more electrons than protons. This is called an ion. Remember that? When you change the number of electrons in an atom, it becomes an ion. So what happens when you gain protons or lose protons? So we just said when an atom loses electrons, it becomes positive. When it gains electrons, it becomes negative. So what happens if you gain protons? You change the atom then, right? So every atom has an atomic number based on how many protons it has. And if you change the number of protons it has, which doesn't really happen except in radiation, then you get a different type of atom. So we're not really going to deal with that. What we are going to deal with is a change in electrons somehow. Okay, so that's how charge comes about. We have a few properties of charged objects. So if you have opposite electric charges, so let's say you have this object is positively charged, this object is negatively charged, they're going to attract each other. Opposite electric charges attract each other. So that means that the positive charge is going to pull on the negative charge that direction, and the negative charge is going to pull on the positive charge also that direction. So they're going to be attracted to each other. Similar electric charges, so we mean positive and positive or negative and negative, they repel each other. So this positive charge would be pushed that way, and this positive charge would be pushed that way. Same thing happens with negatives. Charged objects, positive or negative, attract some neutral objects. You may have had this experience if you have rubbed a balloon on your head and then stuck it to the wall. So when you rub a balloon on your head, electrons from your hair are being transferred to the rubber of the balloon, and so the balloon becomes negatively charged. This negatively charged balloon is going to possibly stick to the wall because negatives and positives attract each other. So it's not that this wall is positive, it's that it has both positive and negative charges in it. But the negative charges, because of this negative charge over here, the negative charges are repelled from that spot on the wall, and so that spot on the wall just becomes mostly positively charged, and so they're attracted to each other. So although this whole thing is neutral, when you put a charged object next to it, it kind of rearranges the charge in the neutral object to make it partially positive there, and so partially negative somewhere else. Okay, this is an example of charging that we're going to get to right away. So you can charge objects three different ways. The first one is friction. So rubbing a balloon on your head, that would be an example of charging by friction. You are physically removing electrons from your hair and they're sticking to the balloon. Okay, so the balloon ends up with extra electrons on it. So that's friction. The second way is called conduction. This is transfer of electrons through contact. Transfer of electrons through contact. Okay, so for instance, if you plug something into the wall, the prongs of your plug are contacting the electrical contacts on the inside of your wall socket, and so electrons are transferring from your wall socket to the plug that you're plugging into it. That would be conduction. The last one is induction. Okay, this one I'm going to draw you a picture of because it's difficult to explain just with words. So what we did over here, this was partial induction. So it involves taking a neutral object. So the neutral object has positive charges in it that aren't going to move around because that's the protons make up the structure of that object. And it's going to have negative charges that are a bit more mobile in the object. So if we, near to that object, brought close another charged object of some kind, so let's say this was a negative object that we brought close here. The charge in this negative object is going to repel the charge in this neutral object, and so the charges are kind of going to rearrange in here. So we still have the positive charges where they were before. They are not very mobile, they just stay where they were. But now the negative charges are all going to move around, and they're going to tend to get to this side. Okay, so the negative charges in this object have now been pushed to this side because they're repelled from this object. Now, if you take a wire, let's say, a rainbow wire, and you attach it to the ground, this is called grounding an object. So the ground, literally the earth, will accept as much negative charge as you can throw at it. And so these negative charges over here are now going to get attracted to the earth. They're going to flow down the wire and basically drain off of this neutral object. So then what ends up happening is when you break this connection, now all of the negative charge from this object has been drained off, and you end up with a positive object. That's charging by induction. How things are charged also depends on the type of material we're talking about. So the first type of electrical material would be called a conductor. A conductor is anything that allows electrons to move freely. Okay, so a conductor allows electrons to move freely. Or at least somewhat freely. Not everything conducts electricity the same, and so some things are sort of conductors, some things are really good conductors, and anywhere in between. The second classification we have are insulators. And where conductors allow electrons to move freely, insulators don't. Okay, so a type of conductor you might often see is copper or aluminum or gold or silver. Okay, those are all great conductors. You might have noticed that on your nice pair of headphones that you own, the headphone jack end is probably coated in gold if it's a nice pair of headphones. But gold is not the best conductor out there. Silver is the best conductor there is. So why would you coat a headphone jack in gold, a more expensive metal, versus silver, which is cheaper and a better conductor? Well, silver also has some kind of negative properties to it. It tarnishes pretty easily, and so gold doesn't do that type of thing. Silver is going to wear away and kind of break down because of that tarnishing thing. It would be annoying. So they use gold because it's a really good conductor and also doesn't tarnish. Insulators, rubber, ceramic, glass, etc. There's lots of them. And then there's a whole set of materials that kind of fall somewhere in between. So wood is not a good conductor at all. It's kind of an insulator, but it might conduct some electricity in certain circumstances. So if it's wet wood, it's going to conduct electricity better than dry wood, but it's still not really a conductor. Okay, so these are the two basic categories, but there's all sorts of stuff in between.